Okay, so this is the fifth video in the series on exponents and polynomials. So far, we've talked about what exponents are, what exponential notation is, and we talked about the different laws of exponents. And then after that, we did do a quick unit on scientific notation. So at this point, we're going to start the study of polynomials, okay? So we'll start with a few definitions and some examples, and then we'll go into adding, subtracting, multiplying, dividing polynomials. So let's start first with a monomial. So a monomial is a variable, a constant, or the product of a variable and a constant. So if you go back to algebra, like the beginning of algebra, when we talked about linear equations in one variable, we had a definition for a term. And the definition of a term is it's a variable, it's a constant, or it's the product of a variable and a constant. So basically a monomial is kind of like a single term in a linear equation in two variables. But at this point, a monomial doesn't have to be in a linear equation. It could be in a quadratic equation or some higher degree equation. So a monomial is just a variable all by itself, a constant, which is a number all by itself, or you could multiply the product of a variable and a constant. And then I'm going to put a little note here. You can have monomials with multiple variables. And we'll talk about those in just a bit. Okay, so you could have the product of a variable or variables and a constant. So some examples of monomials could be something like x, negative y, 14. You could have something like 12x squared. You could have something like negative 3xy. You could have 15a squared b to the third times c. Okay, all of these would be examples of monomials. What you'll notice within a monomial and in any kind of monomial, whether you have one variable or multiple variables, is you can have a positive or a negative monomial, but within your monomial, you will not see addition or subtraction. It's just multiplication. Okay. Now, we need to talk about the degree of a monomial. And when you're dealing with the degree of monomials, you have basically two cases that can come up. You can have a situation where you have a single variable. If you have a single variable, degree is super simple. Degree equals, so degree equals the exponent on the variable. So for instance, if I had negative 5x, the degree would equal 1. If I had 12x to the third, the degree would equal 3. If I had negative 2y to the seventh, degree would be 7. And then you have a wacky situation where you have no variable. So let's say I just had 13. Okay. In this case, the degree is 0. And there's a good reason why. Okay. So if you have something like 13, we already know from a previous video that, for example, if I had like x to the 0 power, that really just equals 1. So anything to the 0 power is equal to 1. So imagine this 13 is multiplied by x to the 0 power. So I really get 13 times 1, or just 13. But secretly, we have this x to the 0 power, which would tell us that the exponent on x is 0. We know the degree of a monomial is equal to the exponent on the variable. So that's kind of how we secretly get that degree of 0. So anytime you have a constant has a degree of 0. Anytime you have a monomial that has just one variable in it, you simply have to look at the exponent. Okay, so I'm going to erase this side work over here, and we're going to talk about what happens if you have a monomial with more than one variable. How would you determine the degree? So if you have a multivariable monomial, the degree equals the sum of the exponents on the variables. So let's say I had 3x squared y. Well, in this case, the degree is going to equal the exponents that we have. So we have an exponent of 2. And then you have to remember from a previous video, if there's not an exponent on something, it's always assumed to be an exponent of 1. So we have this single 1 here, but we don't see an exponent. So we would pretend the exponent is just 1. So the degree here would be 2 plus 1, or 3. Okay. So I could have something like negative 8x to the third y to the 7th. Well, the degree here would end up being 3 plus 7, or 10. I could have something like negative x y to the third z to the 10th. The degree here, well, I have a pretend 1 on my x, so my degree would be 1 plus 3 plus 10, or 14. And again, don't forget, if you have a plain old constant, so 27, let's say we have negative 27, the degree here would still be 0. Okay, so single variable, the degree is just equal to the exponent on the variable. Multivariable, the degree is equal to the sum of the exponents on the variables, and be on the lookout for those sneaky exponents of 1. And then if you're dealing with a degree of a constant, it is always 0. Okay. So next up, we need to look at the idea of a polynomial. So the title of this entire unit is exponents and polynomials. So let's figure out what a polynomial is. So polynomials, a polynomial is the sum or difference of terms So we're going to change it to this monomial talk, and we're going to say it's the sum or difference of monomials. Okay, so if you go back to the introduction to algebra where we talked about linear equations in one variable, we talked about terms being a constant, a variable, or the product of a constant and a variable. And then we talked about an algebraic expression, and we defined an algebraic expression as the sum or difference of terms. A polynomial is kind of the same thing. It's the sum or difference of monomials, but there are a few conditions, okay? So some conditions on this: exponents must be positive. Exponents must also be whole numbers. Okay, so you can't have negative exponents because a negative exponent puts a variable in a denominator, which is problematic. And then exponents have to be whole numbers. If you have an exponent that's like a fraction, that really relates it to a radical expression. So you'd have a variable under like a square root or a cube root, and that would make it not really a polynomial. So these two conditions here must be met. Okay, so examples of polynomials: you could have something like x squared minus 5x plus 10. You could have something like 3x to the third y to the fifth minus 10. You could have something like 8x to the fourth minus 9x cubed plus 6x to the second minus 9x plus 14. Those would all be examples of polynomials. Non-examples, so stuff that would not kind of fit the definition, would be if I had x to the negative 2 minus 9x to the negative first plus 6. If I had something like 3 square root x minus 10, that would be a problem, okay? If I had something like 5x plus 3 over x squared, that would be a problem. So when you're dealing with a polynomial, you have to kind of meet these definitions of, or not these definitions, but these conditions of having a positive exponent and a whole number exponent. Now, there are special types of polynomials. You already know one. A monomial is a single term. So it's just a single piece to a polynomial. You then have a binomial. We work with binomials a lot. A binomial is two terms, okay? And then we have a trinomial. this would be 3 terms. Okay, now you can have a multi-term situation, and we just call that a polynomial. Let me actually reverse how I wrote that. So then we have just a polynomial. Sorry, I switched to black by accident, which is multi-term. So polynomial is kind of like the generic definition that just says it's any number of monomials added together. Okay, but monomials, binomials, and trinomials, we use them all the time, so they got their own name. So a monomial could be something like 5x squared. A binomial could be something like x squared minus 9. A trinomial could be something like x to the third plus 3x squared minus 4x. A multi-term polynomial could be any of the 3 that I've already shown you, but you can have more than 3 terms. We could have something like 5x squared minus 10x plus 3y squared minus 6y. Okay, that would still be considered a polynomial. It just is a polynomial with 4 terms. Okay, now when you're dealing with degree of a polynomial, you have to understand what we already talked about when we talked about degree of a monomial. So remember, when you're dealing with the degree of a monomial, you have a single variable situation, and the degree is really easy. It's just the exponent on the variable. If you're dealing with a monomial that has multiple variables, you would then look at the sum of the exponents on the variables. So when we're looking at the degree of a polynomial, we basically say the degree. So the degree of the polynomial is equal to the degree of the single term with the highest degree. Now, in my years of teaching, I have tried to come up with a smoother way of saying this, and nothing is necessarily smoother than the last statement. But basically, when you look at the degree of the polynomial, what you'll do is you'll look at the individual degree of all of the monomials that make up the polynomial. Whichever single monomial has the highest degree, or whichever single term has the highest degree, that becomes the degree of the entire polynomial. So for example, we'll do an easy example. If I have x squared minus 3x plus 7, well, this first term has a degree of 2. The second term has a degree of 1. And then the third term, remember, constants have a degree of 0. So basically, the degree of 2 is the largest degree for a single monomial. So the degree of this polynomial is going to be degree 2. Now, where it could potentially get a little bit complicated is if you have multiple variables. So let's say I had 3x squared y minus 9xy plus 13. Okay, so for the first term, the degree is going to be 2 plus 1, or 3. For the second term, the degree is going to be 1 plus 1, or 2. For the third term, the degree is just 0. Well, the highest degree of a single term is 3. So we would say the degree of this polynomial is 3. Okay. And that's really it for the degree. You just have to be really careful. So again, let's look at another example with lots of variables. So let's say we have negative 5x to the third y squared plus 7x squared y squared minus 9xy squared plus 3xy minus 10. Okay. So if we look at the degree of each individual term, for this first degree, negative 5x to the third y squared, we would have a degree of 3 plus 2, or 5. And then for the next term, we have a degree of 2 plus 2, or 4. Then we have a degree of 1 plus 2, or 3. Then we have a degree of 2. Then we have a degree of 0. So we can see the single term that had the highest degree had a degree of 5. So the degree of the entire polynomial would be 5. Okay. So then one more example, we could have something like 3x plus 7y equals 2. Let's not even put equals, let's put plus or minus. There we go. So here the degree of the first term is 1, the degree of the second term is 1, the degree of the third term is 0, so we would say this is a degree of 1. So it's a first degree polynomial. All right. Now, when you're dealing with degree of polynomials, a lot of these will come up frequently. So if you have a first degree polynomial, this is what we call linear. If you had a second degree polynomial, this is what we call quadratic. All right, so some of these things are going to show up over and over. A third degree polynomial would be cubic. Okay, so a lot of these are going to show up repeatedly. They show up so often they get their own names. So later in this course, you'll potentially deal with quadratics, and hopefully you already recognize the linear. Okay, so let's look at a few other things. So one thing I do want to show you is standard form of a polynomial. Now, standard form of a polynomial can get a little dicey. So we're going to focus on a single term or a single variable polynomial. So for single variable, put the terms in order from highest to lowest degree. Okay, so if I had something like -15 plus x squared minus 9x, this would not be in standard form. And our goal is to always put our answers in standard form. So what you would want to do is look at the degree. So I have degree equals 0, degree equals 2, degree equals 1. So what I would do is I would put these terms in order from the highest to the lowest degree. Just be careful with your signs. Make sure your sign follows your term. So this would technically be x squared minus 9x minus 15. This right here is your standard form. Now, when you have multivariable situations, I've seen this in different books written out different ways. So one textbook that we used frequently said, basically do this. Okay, so one book says this. Other books do it differently. So the best way to explain what they do is to show you an example. So let's say we had 13xy minus 8 plus 2x squared y minus 4y squared x. Okay, so let's say we had something like this. What they do is they look at this alphabetically. So they find whichever variable comes first in the alphabet, so the x. So they would put the terms in order based on the x's first and then the y's second. So it gets a little dicey with something like this. So they might put it in order saying it's 2x squared y, and then they would do minus 4y squared x, and then 13xy, and then minus 8, okay? Luckily, you don't see this so much. You'll see polynomials like this, but you don't get asked to put them in standard form all that often. Something like this, you definitely need to know. You see this pretty frequently. So just be on the lookout for this. I'm not going to put a lot of emphasis on standard form because it's not something that you have to lose a ton of sleep on. But later when we talk about factoring, you do start with your polynomials in standard form and so forth. But it's going to be pretty easy stuff like this example with x squared minus 9x minus 15. All right, two more things I want to cover. We want to talk about evaluating polynomials, and we want to talk about simplifying polynomials. So let's look at evaluating. So this is something that you would have done when you were first talking about linear equations in one variable. So the way you start that is you talk about algebraic expressions and how to evaluate those. And it's no different here. So when you're evaluating polynomials, you're replacing the variables with given values. And then you use the order of operations to simplify. So it's exactly the same here. You're not doing anything any different than what you would have done when you first start the unit on algebra. So let's say that we had x squared plus 2x minus 9. and we're going to evaluate it for x is 5. Well, anywhere you see an x, you want to use parentheses and replace the x with a 5. So we get 5 squared plus 2 times 5 minus 9. I want to take care of my exponent first, so 5 squared is 25. We can go ahead and look at 2 times 5, which is 10. Then we subtract 9. Well, 25 plus 10 is 35. 35 minus 9 is 26. So if we were to evaluate x squared plus 2x minus 9 for x equals 5, we should just get 26. So I say we look at like maybe 2 or 3 more examples, then we'll look at simplifying. So next up, we have 3x squared minus 6x plus 5. And we want to evaluate for x is -1. Use parentheses, okay? This is an example that would be most commonly missed among students at this point. Whenever you replace the variable with some numerical value, you want to use parentheses. And it's especially going to matter if you have exponents on the variable. So like in this first term, we have 3x squared, but x is -1. So now we know that x is -1, and we have to go back to one of those previous videos in this series where we talked about what to do when your base is negative. If your base is negative and in parentheses, your exponent tells you if it's going to be positive or negative. So here we have a -1 in parentheses with an even exponent. So that means this is going to simplify to be positive. Even exponents make the product positive. Odd exponents make the product negative. And then 1 squared is just 1. So -1 squared simplifies to plain old 1. Now, -6 times -1 is going to be +6, and then we just drop down the plus 5. Well, 3 times +1 is 3. So what I really have is 3 plus 6 plus 5. Well, 3 plus 6 is 9. 9 plus 5 is 14. And that's it. Let's try, I guess, just one more. So let's say we have 5x to the third minus 2x squared plus 7x minus 4. And we're going to evaluate this for x is -2. Okay. So again, use parentheses. We would get 5 times -2 for x squared minus 2 times -2 for x squared. Whoops. This first one should be cubed. Plus 7 times -2 minus 4. Well, -2 squared, again, you've got a negative in parentheses, but this time we have an odd exponent, which makes this product negative. So I'm going to get 5 times negative, and then 2 to the third is 8. Next, I have -2 times, this time I have -2 in parentheses with an even exponent, which is going to make it positive, and 2 times itself once is 4. 7 times -2 is -14. Drop down your minus 4. 5 times -8 is -40. -2 times 4 is -8. Drop down your minus 14 minus 4. Let's see here. We've got -40 minus 8, which is -48. Minus 14 minus 4. Well, -48 minus 14 is going to be what? -62. Minus another 4 is -66. So there you have it. Now, you could certainly have a situation where you have multiple variables. It would be the same thing. You're just going to be given 2 replacement values. So if you had like an x and a y, actually, let's just go ahead and look at an example. Let's say that we have x squared plus 2xy plus 4y squared. In this case, since you have 2 variables, you'll get 2 replacement values. So we're going to evaluate for x is 2, y is -3. And you do just like you did in the previous example. So use parentheses when you replace the variables. So I get 2 squared plus 2 times -3 plus 4 times -3 squared. Let's go ahead and deal with our exponents. So 2 squared is 4. And then -3 squared is 9. We'll go ahead and deal with the multiplication next. 2 times 2 is 4. 4 times -3 is -12. And then 4 times 9 is 36. So 4 minus 12 is -8. -8 plus 36, let's see, would be what? 28. And there you have it. Okay. So the last thing I want to talk about in this particular case is simplifying a polynomial. And just like before, when you first learned about algebraic expressions, what you did is you evaluated algebraic expressions and you simplified algebraic expressions. This is simply combining like terms. Now, maybe you forgot. Let me fix that. That looks crazy. Simplifying like terms. And just remember, like terms are terms with matching variable parts. So for example, I could have something like negative 5x squared plus 3x minus 9x plus 12 minus x squared. So we have basically three different types of like terms here. We have the terms that have the x squared. So those I'll underline in red or blue. We have the terms that have just an x. I'll underline those in red. And then we have the constant term. Okay. So each thing that matches, we would combine using adding or subtracting, and then we would write it out in standard form. So we'll start with the x squared. You always start highest degree to lowest degree. So negative 5x squared minus 1x squared is like negative 5 minus 1, or negative 6x squared. 3x minus 9x is like 3 minus 9, or negative 6x. And there's nothing to combine with that 12, so I would just drop it down. All right. Let's try another one. Let's say I have 3xy plus y squared minus 4xy plus 12 minus 3. Okay, so starting with the highest degree, we have a y squared. We'll call it the highest degree, even though there are multiple terms that have the degree of 2, but we're going to start with just a single y squared. We'll then move to the xy terms, and then finally we'll wrap it up by looking at the constants. Okay, so there's nothing to combine with y squared, so I would just bring it down. If I then look at the xy terms, 3xy minus 4xy would just be minus 1xy, but the way we write it is just minus xy. We don't include the actual 1. And then 12 minus 3 is 9, and that's it. So that is simplifying a polynomial. You could have something like this where you do have parentheses, all right? So when you are first learning how to deal with algebraic expressions, again, you learn how to evaluate, then you learn how to simplify, and we learn something called the distributive property. So the distributive property would be used here for this negative 3 times 9x minus, or 9x plus 7. So what I would do is I would simplify everything first by dealing with the parentheses. So I'm going to drop down my 14x. And then I'm going to take negative 3 and multiply it by 9x, which is negative 27x. I'll then take the negative 3, multiply it by 7, which is minus 21. And then I'll drop down my 15. And at this point, I have x terms and I have constant terms. So let's look at the x terms first. 14x minus 27 is the same as 14 minus 27, or negative 13, and then keep the x. And then negative 21 plus 15 is the same as like 21 minus 15, which is 6, but we would keep it negative. And that's it. Let's do maybe one more kind of like that. Let's say for this one, we have 21x minus, and then in parentheses, x squared plus 3 plus 2x squared minus 8. All right. So same thing, I'm going to go ahead and simplify by getting rid of the parentheses, then we'll simplify further. So I'm going to drop down my 21x. And then what might be a little bit unknown, or might be something you forgot, is right here in front of the parentheses, there's no number, but we would assume it's just a 1. So I'm going to distribute a negative 1. So negative 1 times x squared is negative x squared. Negative 1 times 3 is negative 3. And then I'm going to drop down plus 2x squared minus 8. So I have x squared terms. I'll underline those in blue. Those will get combined. I have a plain old x term, and then I have 2 constant terms. So we'll start with the x squareds. I have negative x squared plus 2x squared. So that's like negative 1 plus 2, or 1. So I would just get x squared. And then there's nothing to combine with 21x, so I'll just drop it down. And then negative 3 minus 8 would just be negative 11. So there you have it. Now, one thing that I didn't discuss in this video, but I guess is worth at least mentioning, is coefficients. So this goes back again to when you first learn how to deal with algebraic expressions and you first get your introduction to algebra. One thing you talk about is a coefficient, and this is the numerical factor of a variable term. So if we had something like negative 9x, we have two factors here. We have negative 9 and x. Remember, factors are things that are being multiplied. And the definition of a coefficient is that it's the numerical factor of a variable term. So the coefficient here would be negative 9. I could have something like 14x to the third. The coefficient here would be 14. I could have something like negative y. The coefficient would just be negative 1. I could have something like 2/3 x. The coefficient would be 2/3. You could also have something kind of wacky, like let's say x over 5. Well, if we ignore the 5, we would have a coefficient on the x of 1, but then that 1 would be divided by 5. So I could also have something like 2x over 7. Well, the coefficient here, again, would be 2/7. So if your term looks like a fraction, it's going to have a fraction as the coefficient. So just don't forget those coefficients. So if we go back and we look at some of these, so if we look at, for example, where I give you the definition of monomial, and then we look at different examples, the coefficient of x would be 1. The coefficient of negative y would be negative 1. When you're dealing with a constant, sometimes people would say the coefficient is just the constant itself, or 14. The coefficient of 12x squared would be 12. The coefficient of negative 3xy would be negative 3. The coefficient of 15a squared b cubed c would be 15. So just don't forget that definition. That's one definition that I didn't really go over earlier in this video. Okay, so quick recap: a monomial can be a variable by itself, a constant by itself, or the product of a variable or variables and a constant. If you're dealing with the degree of a monomial with a single variable, the degree is equal to the exponent on the variable. If you're dealing with the degree of a monomial that has multiple variables, the degree is the sum of the exponents on the variables. And if you have a constant, I gave you two examples here, the degree of a constant is always 0. We defined a polynomial as just the sum or difference of monomials. We looked at some examples. We did realize that there are going to be conditions. Exponents have to be positive and they have to be whole numbers. So no fractions, no negative exponents. You can't have a variable under a radical because that would end up being an exponent that's like a fraction. We talked about a monomial, a binomial, a trinomial. We looked at the degree of a polynomial. Remember, when you look at the degree of a polynomial, you find the degree of the individual terms, and then whichever one is the highest is going to be the degree for the whole polynomial. We talked about standard form. Again, standard form isn't something you have to go too deep in because it can get a little bit dicey if you have multiple variables. If you have a single variable, degree is easy, just go highest to lowest degree. Or standard form is easy, just go highest to lowest degree. We talked about evaluating a polynomial, so you just replace the variable or the variables with given values and then simplify. And then finally, we talked about simplifying polynomials. We did several examples, and then we looked at coefficients. So that pretty much sums up an introduction to polynomials. So in the coming videos, what we'll do, my hair is kind of erect. What we'll do in the coming videos is we'll look at adding and subtracting polynomials, which is really not hard. The only issue with adding and subtracting polynomials is going to be signs. So just beef up on your signs. Remember how to add, subtract, multiply, divide. We'll then look at multiplying polynomials. We'll look at special cases with multiplying, and we'll look at dividing polynomials. So there's a good bit coming in the coming videos, but all of it is pretty okay. It's not the hardest stuff you're ever going to do. So that's it for this one. Best of luck.